All right, for this problem, we want to find and classify the discontinuities of f of x is equal to the rational function x squared plus 9x plus 20 over x squared minus 16. And the first thing you want to do is write this function in its factored form. So f of x can be rewritten as x plus 4 times x plus 5 divided by x plus 4 and x minus 4. From here, we can see that there's two places where this function is going to be undefined. By taking our denominator and setting it equal to 0, we have x plus 4 equals 0 and x minus 4 equals 0, giving us x equals negative 4 and x equals positive 4. Well, first take a look at what happens when x approaches negative 4. So we're going to take a look at the limit as x approaches negative 4 of our function again, x plus 4, x plus 5 over x plus 4, x minus 4. We know that's equal to the limit as x approaches negative 4 of x plus 5 divided by x minus 4. Thinking again that these x plus 4's cancel. And again, it's all about the approach towards negative 4, not the actual value at negative 4. We now calculate this limit by direct substitution, and that limit is going to be equal to negative 4 plus 5 divided by negative 4 minus 4. And that's going to be equal to, it looks like, negative 1/8. All right, so the limit exists at that point. So that's going to make x equals negative 4 a removable discontinuity, or again, a hole in the graph. All right, we also have to now check out the other location, which is positive 4. And you'll notice that when you take the limit as x approaches 4 of x plus 5 over x minus 4, this limit does not exist. Because we cannot directly evaluate it. So instead, we need to take a look at either the left or the right. So let's take a look at the limit as we approach 4 from the right side. If we make a quick table of values, we can take a look at 4.1, 4.01, 4.001, and see the values of f of x. And we'll pause right there so we can pull up a calculator. And from our calculator, we will see that we get the value of 91, 901, and 9,001. So it's pretty obvious that we are going towards positive infinity for that right limit. So since we're going to infinity, x equals positive 4 is a vertical asymptote. So we have a vertical asymptote at 4, and we have a removable discontinuity at negative 4.